Hey everyone, how's it going? I'm James Montemagno. I'm so excited to be here back on .NET Conf. Today I'm going to be talking about how we can start building iOS and Android apps completely in C# inside of Visual Studio with Xamarin, which is pretty awesome. I'm super excited about Nugetizer 3000. Thanks Miguel for that. And it was amazing to see kind of the walkthrough and see the future. Now what I'm going to do today, I'm going to walk through specifically how to kind of get started with Xamarin and what it means to go mobile with Xamarin and C# and kind of build these native applications. So I'm going to go through exactly how Xamarin works and kind of our different architectural approaches. And later today, Nina from our team will be going through Xamarin Forms. So if you're looking forward to that, check it out later. So maybe wondering, well, who am I if you've never seen me? Well, I'm James Montemagno, and I'm a developer evangelist here at Xamarin. I love my job because I not only get to talk at amazing developer conferences all over the world and create apps, but also open source everything I do, which is really cool. I live in this beautiful sunshiny city of Seattle, Washington. I drink way too much coffee, so even though it's bright and early, I guzzle it. So if you're ever here in Seattle, just ping me and let me know, and I'll take you guys out for coffee. And of course, I love building mobile apps. And like I said, I open source everything I do, so all my samples, all my apps that I ship, and all my libraries are all on my GitHub page. You can contact me anytime. That's my email, james@xamarin.com, and my Twitter and GitHub page, which is James Montemagno. But let's talk about Xamarin. And normally when I've been talking about Xamarin in the past, we've been talking about the develop parts of Xamarin, which is building those iOS and Android applications inside of Visual Studio. And that's kind of been our core, our platform, if you will. But when you think about what you need as a complete mobile solution, it's a lot more than just building. You want to be able to test. So we built the Xamarin Test Cloud, which is over 2,000 unique iOS and Android devices. And we created a free toolkit called UI Test, Xamarin UI Test, to create automated UI scripts completely in C# to automate what your users are doing. You can run those locally for free on a device or simulator or send it to the Test Cloud, which is a paid subscription, which is very cool. Of course, kind of like as our acquisition of Microsoft, a lot of the rest of the flows come along too when building applications. I'm really big into continuous integration and continuous deployment. So Visual Studio Team Services, one-stop shopping for building any sort of application. You go, click, set up a Xamarin application, and boom, you're building with every commit to GitHub or TFS or your own Git or anywhere else your code may live. Now, of course, we're building our applications or we're testing them, but we want to ship them and actually get some reports back about how our app's doing once it's live. And that's where Hockey App and our Insights products have come together. So Insights was a product that actually did crash reporting and eventing, and it's been merged into Hockey App, which is very exciting. If you've never used Hockey App, it's one place to go to distribute any of your iOS, Android, or Windows applications to all of your testers. So you can now test, build, push it all out to your testers and get crash reports back, even when it's on the App Store. Let's talk about kind of building these native applications. When I started a mobile application 5 years right here in Seattle, Washington, my boss came in and said we need an iOS, Android, and a Windows app. It's completely native. We need it to be great. We need it to be native. So what does that native mean? Well, I kind of look at it at three important things. I've been doing this for 5 years and have crafted over 80 applications on the different platforms. And to me, I want to make sure that I have a great user interface. I'm an Android user, we have iOS and Windows users, and we want to craft a great experience around the specific widgets and tools that are on each platform. So we want to have access to all those UI, and they got to be great and native. And of course, as developers, we want access to every single API. If there's something that we can do on a platform, we want to do it. And when a new version comes out of the platform, we want to get and start doing it right away. And of course, we want it to be super fast, super performant. As soon as a user clicks on a button, it just works and navigates. It does whatever we need to do. So how do we get there? And how does Xamarin differ? How does the Xamarin approach to mobile development differ? Well, you may be kind of in this silo approach, or may think that you have to do the silo approaches, which is what I thought 5 years ago, which is like I need an iOS application. So I go and I boot up Xcode and I download it and I write some Objective-C or Swift. I get a great native iOS app. And then I got to go over in Java and Android Studio and do the same thing. And I'll be happy over in Visual Studio and C#, which is my favorite language, the best language. F#'s great, they're all great in the .NET world. Or over here, we're living this happy, beautiful world, in Windows world. But now I have 3 teams, 3 projects, all implementing different features at different times. So it gets really expensive and really tedious. You do get great native applications, though, written in the native language. So you think, well, maybe I'll write once, run anywhere. And a lot of people think that that's what cross-platform is. And they're like, oh, cross-platform is kind of this lowest common denominator. And a lot of these write once, run any approaches are sometimes just running in a web browser and kind of emulating and transpiling kind of like different things together. And you put a bunch of HTML and JavaScript in a box and some apps plop out at the end of the day. But since things are normally running in a browser, you're never going to have that great native performance of running on the native platform. And then also, you're going to kind of be limited against their APIs that you're kind of coding against, not the APIs of the platform. So we are completely different when you think of cross-platform with Xamarin. We're 100% native. We're enabling you to build a shared C# backend for all of your applications. All your business logic, so your models, view models, RESTful service calls, SQL databases, things that are the same across the different platforms. Just your .NET code that you want to just run. Then we give you the tools inside of Visual Studio to build out a great native iOS, Android, and of course Windows user interface. You do it all in C# with 100% API access. And if you're wondering how that looks, if you've never done kind of getting started with Xamarin before, is think of it from a Windows API perspective. You know, we've been able to write Windows apps for a long time, or ASP.NET. We have this great .NET library. It's just the .NET runtime running somewhere, and I have these amazing things like Link, I/O, XML. I want to go to a platform, I download an SDK, get some new namespaces. Which is pretty awesome that I can have this shared code just in the .NET libraries. You can think of it exactly the same when you choose Xamarin to build your iOS and Android applications. So over here now, we still have that great .NET on the bottom. And you heard Miguel talking earlier about the kind of that .NET standard. It's the same .NET implementation that you kind of have. You have this great, huge .NET library that's there. So your net, system, I/O, link, XML, data, all that good stuff that you know and love is now running on the Mono runtime, so kind of the original open source implementation of .NET. But we give you every single API in iOS and Android. Create these beautiful C# bindings and wrappers around all these great APIs. Then we add C# features to them. So async await, lambdas, events, delegates, all the C#6 features that are so awesome. So even though you're accessing a native API, you're doing it all in C#. So you never, ever have to write Objective-C, Java, or Swift, or anything like that. You just do it all here in C#. And of course, we do the same on Android. I'm an Android junkie, and I just love all the craziness that's built into that platform. So you get access to all that goodness that's there, but of course that shared business logic backend, which is so important when you're thinking about sharing 50, 60, 70, 80, 90% of code that's highly maintainable. This means that you implement a feature in one place, fix a bug in one place, and your apps are all updated automatically because it's all in your shared code. You have one set of unit tests, one set of UI tests, one place to actually build your applications and then to deploy. One beautiful all cross-platform APIs. We give you great native performance. Miguel talked a little bit about this. But essentially on iOS, we do a full ahead-of-time compilation. Take your C#, compile it down into IL, into LLVM bytecode, run that puppy right through an LLVM compiler and optimizer, and boom, beautiful native ARM binary for your users at the end of the day. On Android, we can leverage just-in-time compilation and run the Mono runtime side by side, the ART or Dalvik runtime and JNI across with our super fast JIT compilation. But to your users, there's no difference, right? To a developer, I just click build, and you don't really care how the compilation steps are working. You just care that it's running and deploying on my device or simulator or shipping it to the App Store. And your users don't care either. They just want to go to the App Store, click download, and they have a great app. And that's exactly what they have. There's nothing else to install, anything like that. You go to the App Store, click download, the app's running on your device, just like any other application, which is beautiful. And of course, we're always up to date. You know, I started 5 years ago. My boss was very concerned about where's this thing going, or what's the next thing. We've been shipping same-day support for iOS since iOS 5, including all the dot iterations too. So iOS 9.3 came out. Well, obviously, big focus on iOS 10 and Android N when it comes out. And Android's a little bit interesting. iOS has this nice long developer preview that goes on, and Google sometimes just ships a new version of Android whenever they want. But recently, they've been doing long developer previews. So we've actually had near same-day support for L and Marshmallow, and we already have an N preview available to start developing for the next generation of the Android operating system. But to me, when I started 5 years ago, it was just a phone. It was a beautiful world. There was like one iPhone. I could hard code values. I could do whatever I wanted. Not anymore. It's a little bit different. You know, things are scaling. There's iPads, iPad Pros. You know, things are huge, and there's all these, you know, different Android devices, like 24,000 different Android devices on the market. But it's not just phones and tablets, right? It's actually Apple Watches and Android Wear and all the Amazon devices and Apple TV. So we have all the SDKs and libraries available to go to those platforms. So you can truly take your C# and .NET code wherever you want. And we have two great IDEs. I'm going to do a lot of demoing right inside of here, inside of Visual Studio. So if you're a Windows developer, when you install Visual Studio, there's a checkbox for Xamarin, or you can go to Xamarin.com and click download, and it'll install the required bits that you need. But it's essentially going to install the Xamarin extension into your Visual Studio 2012, 2013, 2015. Highly recommend 2015, so it's lovely. Including all the updates, so update 2, you're good to go. Now, if you're on a Mac, that's all you have. Like I'm on a Mac, I have a Mac around. Then we have Xamarin Studio, which is a beautiful IDE. Miguel talked quite a bit about that too, about kind of like what we've been doing. It's powered by Roslyn. It's super amazing. And kind of the same features, the same designers are in both IDEs, the same solutions, the same projects open in both IDEs. So that means if you're in a distributed team where you have maybe some iOS developers with Xamarin just going to town on Xamarin Studio, but you're over here on a PC and you're inside of Visual Studio, you don't have to worry about conflicts or merges or anything like that. Same solutions, same projects. And we have the same features like NuGet and the component store, and all these great things are built into both IDEs. So no matter where you're working, you're going to have a very familiar and similar experience across the board. And Xamarin Studio is extremely highly customizable, just like Visual Studio. So truly, anything that you could do in Objective-C or Swift or Java, you could do it in C# or F# too, inside of Visual Studio with Xamarin, which is really awesome. So truly anything that you can do, to the point that you can take any iOS or Android jar library or archive file that's over on iOS, you can take those native libraries and you can create your own bindings, kind of like we do for the native SDKs. So you can take those components and bundle them into your application, write your own C# bindings around them and add features. So you can improve the APIs. So you have async await and all these great things like events. And we have tons of them available already, but maybe there's something new and you just are developing, you bring it over and boom, you're good to go. Of course, Xamarin is included in Visual Studio. All the tiers, so you don't have to pay for it or anything like that. It's just included, including the Community Edition, which is very, very cool. So when you install Visual Studio, Community Edition, or Pro or Enterprise, it's included automatically. So if you have MSDN or if you're on Community Edition, anything, you're really just good to go, which I love. It's been my dream just to have everyone writing apps with Xamarin. So now there's really no barrier of entry. Just start writing some beautiful C# native apps. And of course, Miguel talks a lot about open sourcing, but everything is open source. It's so great. So our iOS, Android, Mac, Xamarin Forms, our plugins, our components, and there's a roadmap. There's all this great stuff that you can contribute, including our Mono runtime, which means that if you're creating like a new game engine or some embedded hardware, you can take our Mono runtime and embed it into that platform and run your .NET code truly anywhere. Which is beautiful. So .NET's native, it's super fast, it's everywhere, everything is open source. It's a beautiful time to be a C# and .NET developer or F# developer in any of our great languages. So how do you get started? Before we jump into some demos, well, you just install Visual Studio. Now, if you do the typical install, you'll get all that, 10 gigs of whatever, and of course you want more gigs of installation, because why wouldn't you? So you hit Custom, that's what I do every time I install Visual Studio. And then you go over here to this beautiful checkbox list of additional gigs of data that I can install on my machine, which is why you always get a nice big hard drive. And you start clicking some stuff. And the first thing that you want to click is the cross-platform mobile development. You'll see C#.NET Xamarin right there. And that's what you want to click. This is going to install multiple things on your machine. It's going to install the Android SDK. It's going to install the Xamarin tooling. It's also going to install the Visual Studio emulators for Android. These are Hyper-V enabled, which are super fast. That's what I'll be using here. I'm also going to be using a physical device for some of the demos later on. But you're going to have everything that you need to get started building iOS and Android applications. And of course, for some reason you had already installed Visual Studio, you could go and say change and install it. If you want any of our documentation, anything like that, go to Xamarin.com or Xamarin.com/download. We have easy installers to get you everything that you need, whether you're on Mac or on the PC with Visual Studio. Now maybe talk about some really cool things. We talked about kind of staying inside of Visual Studio. I'm going to be demoing this. Here is our Visual Studio iOS simulator. We demoed it at Build, released it at Evolve. It's super awesome, and it enables you to kind of never leave your Windows machine. You click debug on an iOS device or simulator, and it just pops up right on top of your PC, and boom, now you're debugging iOS applications right from your PC, so you never have to leave Visual Studio. This is available as a preview today that you can download into Xamarin. It's super fast, and you get all these great features like location changes and rotate and screenshots, things that you would expect from a simulator. Again, this is a simulator, so it's actually simulating the real physical device with all the hardware. So let's talk about sharing code before we actually do some of this stuff. How am I going to share code? Miguel talked about like this .NET Standard and the different things, different pickles and bait and switch. So we want to kind of leverage a lot of things. And the first thing is portable class libraries. This gives you a nice subset of .NET that you can develop against. So it's one assembly, multiple platforms. You just click iOS and Android, and when you do File, New Project, boom, you're going to be good to go. You can select the different versions of Windows you want to support. You also have shared projects. Shared projects aren't an assembly. Like portable class libraries are an assembly with a namespace. Shared projects are kind of like glorified file linking. So portable class libraries are great for library creators if you want to stay maintained in that subset of .NET. Like, I don't want to break this, and if I need to go into the platforms, I'll create an interface and do abstractions with my dependency services and things like that, service containers. Shared projects are like, I just want to write some code. It's going to live inside, like these are all going to live inside of each application as a reference. They show up as little double diamonds. And the shared projects, it just takes anything that's inside of that project, it's just a bunch of files, and it links them for you automatically. So at compile time, they're added to the Android, iOS, or Windows applications. So that gives you some very cool things that you can do, such as conditional compilation. You can access an Android namespace, and you say if __ Android, then access these Android namespaces. Same thing for iOS, same thing for Windows. So you have some niceties that you can do that, but you got to make sure that you want nice maintainable code. So make sure that the whole thing isn't an if-def, right? But it's pretty awesome. You can have multiple shared projects that all get bundled up, which is really, really cool. And of course, you have the wonderful world of NuGet, the NuGet packages, the nuggets, if you will, of glory that you can install. So JSON.NET, HTTP clients, cognitive services, all these great things, Azure mobile apps that you can install, kind of anything that you could add into a .NET application you can bring into your Xamarin iOS and Android portable class libraries. So just go and add them, and you're off to start developing against those APIs. You can see here I have both the Visual Studio kind of version, the newer versions too, and then you have Xamarin Studio. So same NuGet packages, restore, everything like that is all taken care of. Then code sharing, right? You want to share a bunch of code across platforms. There's some very popular applications built with Xamarin. iCircuit by my good friend Frank Kruger here up in Seattle. He's an amazing, amazing developer. Totally worth following on GitHub and on Twitter. Has a wide range of knowledge there. But he built iCircuit, which is a circuit simulator. It's very complex. It's very nice. And he shares anywhere between 70 all the way up to 90% of code across these different platforms. And I know Frank is a diehard iOS guy. He loves it. So he's gone in, and you can see his shared code percentage is a little bit lower over on iOS. That's because he's essentially lighting it up with all these great iOS features. So maybe iCloud integration or implementing with like AirPlay and things like that. So these great different iOS-specific APIs that are there. And you can do the same for iOS, or for Android, or for Mac, or for Windows. It's up to you. But on average, our developers using Xamarin share about 70% of code. And when Nita comes on later and talks about Xamarin Forms, which is shared UI, you can share up to nearly 100%. Excuse me. Ooh, so let's start building it out. Losing my voice, all right. Cool. So I'm going to jump over here into Visual Studio. Now, you've installed Visual Studio. And what we want to do is build an application. And I'm going to start fleshing this application out and kind of doing some really cool things with it. Now, you may be wondering, James, where do I actually get started? Well, like anything else, you go to File, New Project. And we'll walk through kind of the starting points of the application. So if we zoom in here, zoom not working, that's good. We can magnify in right here. We can see I get a few things. We get Android. So these are all my Android templates that are here from UI Test, Blank App, Single View App. We have iOS. So you get some blank apps for watchOS, for UIKit. There's the Apple Watch extensions. So you can do document pickers, photo editing, iPad, iPhone, or a universal iOS app, which is kind of an iPad and iPhone app bundled together. Or you can go into cross-platform, and that's what I did here. And this cross-platform, this cross-platform, what we have here, enables you to do a blank app or a Xamarin Forms app. And what I did here is I did a blank application and or a shared project. So you choose what you want to do and you name it. So I'm going to go ahead and pull this back up here. I'll get out of there. Boom. So that's where you get started. You hit New, and it's going to spin up your iOS and your Android applications and your Windows applications, and there you have it. All right. So let's talk about what I have here. I'm creating this application called Image Search. And what we're going to be doing is going off and searching Google Images for anything that we type in. And then we're later on going to add cognitive services to do facial recognition on those images. And then we're going to extend it to even do crazy awesome stuff. So get ready. But let me show you kind of the normal workflow that we have. So inside of our application structure, let's just walk through it. Just walk through it. And what we have here is a portable class library. This is all my shared code. So this is going to be my models, view models, maybe my helpers, interfaces, things that are going to be kind of the same across the different platforms. So my .NET code. When I come in here, I can say I have .NET. I have a bunch of other NuGets installed here too. So a bunch of plugins that we'll talk about in a bit in JSON.NET, MVVM helpers, and Project Oxford, which is the cognitive services. So I've gone into NuGet. All right, and I've right-clicked and I said Manage NuGet Packages. This opens up, and I can look at my installed packages here. There's all the great NuGet packages that I have installed. Boom. All right. Now if I come back over here, we're going to see that I've structured this with models, view models. I'm going out and I have all these Google search results that are coming in. This is a lot of code. This is a lot of the JSON that is deserialized into C# objects. And then I have my image search view model, and I like to do an MVVM type architecture. So it really abstracts away my business logic from my UI. So this is code that can be shared anywhere. If I come in and I tap on properties, we can see over here that I can deploy to ASP.NET, Windows 8, Windows 10, ASP.NET, or .NET Framework, Xamarin Android, Xamarin iOS. So I could really go through and deploy anywhere I want. So what I do here is I have an Android, Xamarin Android, and a Xamarin iOS application. If I drop this down, we can see this is the native Android application, but all inside of Xamarin. So I have my references, and I have all those great libraries that we saw earlier. But most important here is I have my image search. So that's my shared code. You can see I've installed tons of great .NET libraries and all the support libraries from Android. And Miguel was talking about the linker that'll strip out anything that you don't need. It'll remove that logic. Then in here I have some adapters, some resources, so drawables, layouts, and menus and values. So my images and my Android AXML. And then here I have my iOS application, which essentially does the same thing. I have my references and all the different libraries in Xamarin iOS, and you have Xamarin Android, which are all your iOS and Android APIs, and then your shared code. Then we have our storyboards and our view controllers and our iOS-specific code that we'd be writing there. But the bulk of this application is all handled up inside this image search. So let's take a look at that code. I'm going to jump out here. There we go. So I'm inside of, let's say, my models that I have, and this is what I actually want to code against. And this image results. So I have a thumbnail link, an image link, a file format, title, things that I want to display on the user interface. And that's pretty good, but what I'm noticing here is that if I look at my Google results, it's all like JSON coming back, and we can see that everything was underscores. I want nice .NET-y, C#-y names with my getter and setters. So I have this search item, and I could peek in here, and I have this stuff. So all these different information of the image, and there's an image, and I can peek into there, and then there's all this stuff. So when I go out, I want to deserialize this JSON that I'm pulling based on the search query that I have. And that's all done inside my image search view model. So here I have an observable range collection, which is an observable collection. It allows me to add things really easily. I go out, here's my API that I'm going to hit for my custom search. So I'm going out, I have my nice C#6 string interpolation here. I'm going to pass it a query. I have this Google search service with some nice constant strings for my API keys there. And it's just some .NET code, right? I go out, I create an HTTP client. I go get a string asynchronously, which is super nice. So it's going to save my contacts, so I can go off on a background task, come back on the UI, it handles it all for me. I deserialize that search result. Then, of course, here I'm going to add all of those images, but I'm going to use our good friend Link to essentially create the image results, a new IEnumerable list of image results. So I can take that crazy Google thing. So maybe I switch it out to Bing or switch out to some other image service like Flickr or something like that in the future. I don't have to worry about that, hey, I've hard-coded all these values against the Google API. I did it against my model, what I want to have. So inside of here, I just simply move these context links file format over. And you can see some of these are even on other objects. And I could use C#6 features of making sure that things exist. I just return true or false if something goes wrong. I could log it, probably like do a to-do, log stuff. There we go. Maybe pop up a dialog to our user that something's gone wrong. So let's start building this application. So over in my iOS, I've added all my references. I've added everything that I need. And I'm going to go ahead and tap on this main storyboard file. And the first thing that you notice is if you see over here on my machine, I actually had a Mac set up here. So this PC is talking over to my Mac. It's just sitting there. And all it's doing is it's going to do remote compilations and actually show our designer and our iOS simulator. So it's going to load up our storyboard. And the storyboard is a complete overview of our application. So kind of it could be a chunk, it could be everything in our application that's going to be there, and I can drag and drop different controls and things down. So this will be the first time I spin it up here, so it'll take a few seconds. There we go. And then what I'm going to do is I'm going to pull out some toolboxes here. Boop. And then I'm going to pull out some properties. There we go. And we're also going to set the iOS project as our startup. There we go. And up here we can see I have iPhone and iPhone Simulator. I can tap on that. And now we have all the different iPhone simulators that are available right there. We can see up top here I have some different controls. So show iOS Simulator, and then I'm connected to my build host that's there. If I go over to my toolbox, we can scroll through. So let me magnify this up here a little bit more. We can see here that I have every single UI widget that's in iOS. I can drag and drop over into my user interface. Down here, I have different properties grids. So let's say I tap on this control here. We have different constraints and layouts of where it's going to be. That's a UI text field, and I can name it. I can give it, text here. I could say maybe it's a cute kitty. There we go. We'll change it back to monkey. When we say kitty, and then it updates in the UI. Come back down here. I can say monkey, and then it's going to update again. Oops. There we go. Now, this entire application is just written with a navigation controller, and then we have another view controller here. And what's cool here is that this is a generic UI that you build, and you kind of pin things to different locations on the screen. But I could come in, I could say, well, I want to see what it looks like if it goes like this. And then it'll automatically adjust in scale. So we see the search and the little activity indicator move over, and I can readjust it here back to the generic view that I want. I could go ahead and tap on this text here, which we can see is named text field query. I have a button named search that has a name on it. And then inside of here, I have this collection view. Collection view is a complete overview. It's like grids of rows and columns. And I've specified what each cell is going to look like. If I had more than an hour, I'd build this all out live. I just want to kind of show you what you'd want. But maybe you want to add something in here, and you want to add a new switch. So I come over here, I drag and drop it. It looks good there. Now it's been added. I could name it here. I could go into my layouts or my events, and I could add all the different events that I want. And we don't want this switch, so we're going to delete it. It deletes it from our screen. We're good. So I want to write some code behind. That's the most important part of this application. So I'm going to go over here into my view controller, which is the code behind to that page that I just wrote. And we see the very first thing that I do is we inherit from UI View Controller. So again, we've wrapped all those APIs. We have UIKit, Foundation. These are core iOS APIs. Then we're implementing this IUI Collection View data source. So we can specify what each cell looks like and what data to display. All right. So we have View Controller, and we have lifecycle events like did load, did appear inside of there. And what we can do is we can come over here and we can look at the code that I've generated to actually display the different cells, so that data source. So here we can see I'm just saying get items count, and I just say my view model.images.count. That's a nice little C#6 lambda expression. Then down here I have get cell. So my get cell, I say give me that image cell that I just created. Then I can grab that image, and then I can set the title and set the image here that will automatically download it for me automatically. Cool. So let's actually call that method that we created in our view model. So I'm going to say button search, which is the name of the button. I'm going to say touch up inside, which is a click event in iOS. I'm going to say plus equals, and do sender args. There we go. All right, now I know that this is going to be an async await method, so I'm going to say async in there. And then I want to do something, so I'm going to say button search dot enabled equals false. I'm going to say activity is loading dot start animating, which is that little spinner. Let's say button search at the end dot enabled equals false, or sorry, true. And then I'm going to say activity is loading dot stop animating. Boom. Now what I want to do is I simply want to go out and say await. I can do that. I can say, yeah, await view model dot search for images async. And we're going to pass it a query. Again, that was a text field query dot text. And these are the native iOS properties that are on there. And the last thing I want to do here is simply say collection view images dot reload data. Because, hey, I have some new data. Display that for me. Done. So that's like my click handler with all that code accessing those native APIs. So here's what I'm going to do here is I'm going to come in. We can compile up our iOS application, make sure it's built. So I've written some iOS code here. So compile it up. This is going to compile your C# code for errors and things like that right here, which is nice. And then when I actually want to put it on a simulator or a device, it'll do a remote compilation on my Mac, but then start it right over here on the PC. So let's just give it a second here to compile up, and we'll be good. All right, rebuild successful. iPhone simulator, I'm going to hit start debugging on it. So now this is, again, it's already built up, so it's going to be ready to deploy. And this will just take a few seconds. I haven't started the simulator just quite yet, so it'll launch it here in a second. Launching application in debug mode. There we go. Here's our iPhone simulator that just popped up over onto my Surface. There we go. It's going to launch my application with my beautiful splash screen that you can see here. There we go. It says cute monkey. I can type on search. It's going to do our activity indicator. Now we get these beautiful monkeys. Now I'm on a Surface, so I can actually use my finger to actually swipe through. I don't have to use a mouse or anything like that. And these are some adorable monkeys that are in here. I could say kitty. Now we have some adorable kittens that are in here. Beautiful. Lovely. So now we've gone and we have those collection views and we're doing all the names inside of here, which is very awesome. Of course, now you want to take that over on Android. So let's take a look at that. So over on Android, we'll close some of these files here. So over on Android, what you want to do is kind of do something very similar to what we did on iOS. We want to build out that native user interface. So over here, if we take a look at the file structure, what we can see is I have drawables such as my icons that are in here. I have some layouts. I have an item, I have a toolbar, a main Android XML, some values, so some themes, some strings that are in here. And I just want to open this main Android XML. There we go. And this is going to be our main user interface, the screen that we're going to go to. And we have some very common controls. Over in our toolbox, we have the Android widget, so we have every single widget that's inside of here. We have a recycler view, which is in a support library, so it's like a list of different items. And we describe those items in another file. But what we can see here is if I tap on this right here, I get all the properties of Android on the bottom left in our property grid. We can see the height, the width, our search here. Maybe we want to change the text instead of search. We want to say go. And it updates in the user interface. What this is doing is generating the Android XML and the code behind. We can see I'm in a relative layout, some linear layouts in here, and I even have a progress bar with this ID of my progress. And I'm setting different styles and attributes. I could change the code there, go back and forth, vice versa, and have it there. Now what we want to do is actually create a little bit of code behind here. It's very similar to what we did in iOS world. We went out and a little bit of setup here. I'm creating that view model, I'm creating my image adapter, which will handle what to display for each item. So if I actually went and peeked into here, we could actually see I'm setting the view model. When the collection changes, I automatically update the user interface. I go out, I create my items, I inflate the specific layout that I want, and then I bind up and I set the title and I load an object with this image loader called Picasso. I have my recycler view, I have a layout manager, I have all this great stuff. So what I want to do is implement this button click event. So there's plus equals async event args. What I want to do here is I'm going to say click button dot enabled equals false, click button dot enabled equals true. And what I'm going to also do at the same time is set my progress bar bar.visibility equal to visible. So it actually starts loading, and then progress bar dot visibility equals gone when I'm done. Now, the adapter will automatically update for me, but I still have to go load that data. So I'm going to say await view model dot search for items async. I'm going to say query dot text. There we go. You see here I was finding that edit text where I enter the text. And I'm going to pass it over to my search. So not very much code at all inside my code behind here. But if I wanted to, I could come up and I could access any of the Android-specific implementations here. And usually it's very little code that I have to write, but I do have access to every single control, all the support libraries, material designs, everything like that. Perfect. So I'm going to set my Android application as the startup. There we go. And now we've switched back to any CPU, and from our drop-down menu, we have all of our Android emulators or physical devices. I have a Nexus 6 plugged in right here, but I'm going to first go off to our Marshmallow device, and this is our Hyper-V Android emulator right here. I'm going to go ahead and launch it in debug mode. It's going to build it up locally. There's no Mac required for Android development at all. You just go ahead and click on it, you click debug, it starts building, and it packages up everything right onto your PC. So we'll package it all up, and then we'll see it launch right here on our emulator. So it's deploying. We'll add some click handlers here so we can kind of see the debugging in action. There we go. We're in debug mode. Launches. And there we go. We can come in here. We can say cute monkeys. Cute monkey, hit go. We'll see that we're brought back into Visual Studio at this point because I've hit a breakpoint. I can investigate these the click buttons. I can see that this is a button. I can see all the different properties inside of it that I want to go. I can investigate, the query text that I pass in there. That's cute monkey and all my view states. All right, and I can continue on. It's going to go out. We have the little loader. Boom. We have the same monkeys and beautiful card views. So we're getting a nice Android material design look and feel right here, as you would expect. So your Android users are happy because it looks and feels like an Android app because it is a native Android application. Same thing for iOS right there between the two different platforms. And this is all using that shared code right here. So if we actually go in here, let's do this again. Look at the results. And when we're done, we'll put a breakpoint there. I'm going to go off, and I'm going to say, cute kitty, goes off. And here we go. We have our JSON result back. Here's our JSON. So it's this huge JSON blob, and I can put in a text visualizer. I can see what it is, right? I could go here to JSON to C#.com, paste it in there, generate my classes. Like here's everything that's coming in, which is really awesome. I could close that. Then I'm going to parse it, so we can see that I parsed that back into this object. 10 results came back. And then now we're going to use this link query to continue on. It's gone through, of course, 10 times, so we'll remove that. There we go. And now we have our images, 10 of them in there with very simple, readable results that are coming back here. And continue on. Now we have some adorable kittens. And of course, I'm on a touch screen, so we're good to go. All right. So let's talk about now, what if I wanted to add a bunch of native features to this thing? What if I really wanted to extend it? So let's jump back over to slides really quick. And I want to introduce this concept, right? I wrote this shared C# library. And it's all in C# or it's all in F#. It's all my business logic. But what is this stuff right here? What is this kind of core that I want? This iOS and Android and Windows bits, what is that stuff? Because you saw that I accessed the UI, so you would think, well, it's all the UIs, but it's also those great APIs that are built in the platform. So you have battery, GPS, lights, notifications, text-to-speech, all these different things, media, taking photos. All these different devices are very similar, all the same. So we said, well, what if you didn't have to write all this code and learn the iOS-specific API and the Android API and the Windows API? And what if you could access these native features in the native libraries from shared code? For instance, text-to-speech. What if I just wanted to speak and have the phone talk to me, whatever I was doing? So I should have an API called Speak. Hello world, and it should speak back. But under the hood, it should use things like AV speech synthesizer, text-to-speech, and the speech synthesizers of Windows to do that for me. And that's why we created plugins for Xamarin and Windows. And you can learn about them at xamarin.com/plugins. They're built in the open by amazing Xamarins, but also amazing developers in the community such as yourself, really building and fleshing out these amazing libraries. We're going to use some of my libraries and some of the ones in the community today to add some cool APIs. So what this does is it gives you a plethora of native functionality from a common API. So settings, media, geolocation, all this stuff. So let's actually use some plugins and extend this application. So the first thing I want to talk about and what we're going to do is I'm going to extend it with cognitive services. This is a suite of APIs that allow you to do a whole bunch of things like Bing search, face, video, emotion search, computer vision, all these different really cool APIs that you could do. You could use it for academic or just for yourself. I want to really tap on this emotion API, which allows you to go in and actually analyze the faces, and it does the different boxes here of how happy, the anger, the fear, of the different people in the photo. And it's really good. If it's, we'll see when we actually use it, of what it's going to return. So it has a cross-platform API. It's just a NuGet, kind of like JSON.NET. And I went and I added the NuGet here. And here's what I want to do. I'm going to go into my image search. I'm going to scroll a little bit further down. In my shared code, here's what I'm going to do is I created a very simple API. We can go into my emotion service. So the API for cognitive services is pretty easy. You give it a stream, so a stream of anything, and use it as an image stream. So it's an emotion service client. You recognize async, and you can parse it. And how I parse it here is I go out and I grab all the emotions, and I get a total average of the people or whoever in the actual photo. And then here, I get the happiness level, and I return a string in this get happiness, and these are just static strings. So my view model, it's just going to use this service. So down here, I get the stream of the file just based on the image URL. I pass that stream to the happiness and get the score, and I return that result. Pretty simple. So that's the entire API there. But what I want to do here is I want to pop up a dialog box, and I could go and implement it in iOS and in Android, and then if I do it on Windows, I would do the same. So what I want to do here is I want to add a NuGet package, and I've added it ahead of time here, but this is the ACR user dialogs, which is a cross-platform message box and progress bar dialog service. So what I can do here is after we're done, we have the results, and we have the string that I want to say. We can say user dialogs.instance.alert. You can do an async, and we can pass it in a message, so result. Done. And go ahead and await on this. There we go. You can add a breakpoint here. This will automatically show the correct user interface for iOS or Android or anything like that. So now I just need to call this method over in Android. So let's go back to my main activity and come over here. I'm going to say adapter dot item click. I'm going to do sender or async sender args. Oops. Just like we have, so another click handler, but for each item in the list. Here's what I'm going to do. I'm going to copy some of this code because we want to do the same thing. There we go. Now what we want to do is every time we click on one of those items, I want to go ahead and not query for it, but I want to go ahead and say analyze image async, and I'm going to say view model dot images. Let's index in on this, and I'm going to say args dot position dot image link. So pass it the image, and it'll handle it for me automatically. So notice I'm not popping up any dialogue or anything like that that's in my shared code. So let's rerun this code here. So recompile it up with all this new logic that I've added in there. All right, so I'm going to say cute monkey again, or maybe cute kitty. There we go. Get some kitties back. There we go. We can get rid of these breakpoints. We don't need those anymore. All right, so I have these kitties. I can tap on one. It's going to go out, comes back. We can see my result. It says unable to analyze image. Okay, that's no good. It's interesting. All right, we'll try this other kitty. It's gone out. Unable to analyze, and that's because the emotion service is smart enough to know this is not a human being. It doesn't know how to do it. So let's check out one of my favorite people in the world, Miguel de Icaza. There we go. There's Miguel, and we can actually tap on him here. How happy is he? He's 89.93% happy in this photo. How about here? He looks very angry. 0.4%. And of course, is it even good enough to see his avatar on Twitter? Nope, can't do it. So you can actually go out and it's going to find the rectangle, it's going to find how happy that photo and the person in that photo is, which is cool. And of course, I could do this again on iOS, and the same code, I would just call that one method. But let's take it a step further, okay? What if I want to actually take a photo of myself and put it into this thing? So let's go back to my main Android XML, and I'm going to go ahead and add another button here. Where's my button? Go up here, I'll say button. Put it down here. There we go. All right, maybe we'll put it in the source. I've added all these buttons, so that's good. All right. All right, so we have a button, and this is called button 1. And that's good. We're just going to give it some text and say, we'll wrap content, and we'll say photo. There we go. So now what we're going to do in our code behind of our activity here is we're going to access that button and then call out to another method. So let's actually go build that method. And here it is. It's called take photo and analyze async. So it's a very simple cross-platform API. You see I was testing it earlier. So what I do is I go in and I say, do I want to use camera or maybe not use a camera? I'm going to initialize. I'm using the media plugin. So what I've done here is I can actually take a look at all my plugins if I go into my NuGet right here. I'm going to say I have a current activity plugin, permissions plugin. Then down here I have a media plugin, geolocation plugin, all these great services available to me. So here's the API. I say crossmedia.currentInitialize. It's going to initialize it. Say, hey, do I want to use the camera or not? I want to try this on the simulator in a bit for iOS, and it doesn't have a camera, so I'll have to pick a file from the stream. So here I can say file, crossmedia.current, take photo. I'm going to say, hey, save it to the album and save it as test.jpg, and that's it. I could come in, I could set different attributes on it, such as photo size, the default camera I want to use. Else, just simply pick a file. That's it. And what this is going to return to me is a media file. This thing has a media file, an album path, a path, and you can get the stream off of it. It's very convenient. So here I can say, well, maybe no photo was taken, they exited out of it. Else, just call that same exact emotion service and say get stream and clear it out. And that's it. And I can say get the happiness level and then return it here with that same dialog result back, but I'll say OK here. All right. So now what we want to do is back to my main activity. I'm going to go find that other button, var photo equals find view by ID. It's going to be a button, resource.id, button 1. And I'm going to say photo dot click plus equals, again, to async sender, sender args. There we go. Now what I want to do in this instance is I'm going to stop here and I'm just going to say await view model dot take photo and analyze async. And we see by default it's actually going to use the camera as true. So I want to do this on a physical device, my Nexus 6 that's sitting here. I'm going to go ahead and screen mirror it here with an application called Visor. It's really awesome. Here it is. I'm going to bring up our Nexus 6. There we go. It's just a blank screen. So I'm going to debug this on a real physical device, which is cool. And all I did was install the drivers for this phone. All the Google Nexus devices are automatically installed for you when you install Xamarin. If you have a special Galaxy device or some other type of Android devices, there's a lot out. You might have to install the Android the ADB, the Android Debug Bridge drivers for that specific device. So here we go. Pull up the simulator again. So launching the application. There's my photo button. Tap on that. Launches me into the camera. There's me. Let's try a few photos. Goes back into the application. It's going to analyze it. We didn't do anything, so we're just going to wait around, see what happens. Boom, 0%. Frowny face. Let's try it again. See how that is. It's a little bit scary. I don't know. 52. Let's see if we can get better. Yeah, there we go. 96.97% of a happiness emotion on my face, which is very cool. Pretty awesome. All from ShareCode. I didn't have to go learn the Android or iOS specific APIs. I have them all right there, which is super awesome. So now I could come back over to my Solution Explorer. I could go ahead and say, you know what? What I really want to do over here is I want to go back into my iOS API and stuff here, and I could say navigation item dot right bar item equals new, and we'll say, you know, what I want to do here is create a new bar item, so UI bar item system item dot camera, and then what I could do here is I could do async delegate, and I could say what I want to do here now is say view model, await view model dot take photo async, and I could say use camera false, and I could analyze that photo. I could reset the iOS project as my startup. There we go. Could go relaunch this now. We come back to my simulator. Let's make sure that we have an image. There's me. That's good. So we'll go ahead and make sure we save an image here, just to be sure. All right, so it's going to relaunch the application. There we go. And make sure we have a navigation item. Perfect. There we go. I get a little camera up top. I'm going to say pick, access to photos, camera roll. There's me. It's going to go off and analyze it. Boom, 100% happy, and we're good to go. Awesome. And I've done that all from shared code. It's pretty mind-blowing just to have it all right here available to me. And of course, I could search, I could do all that stuff, but one place for all of my business logic right there. Now, of course, you want to get started. So obviously install Visual Studio or head to Xamarin.com with a plethora of developer documentation, getting started guides, any of your questions, troubleshooting, anything like that is right there. Amazing videos. You can find all of our videos for our Evolve conference online, like all this good stuff. And of course, later today, Nina will be talking on Xamarin Forms, which is our cross-platform user interface. And with that, thank you guys so much.